Hello, greetings. So for this lesson, we shall now study this very controversial mineral known as dolomite. Now, dolomite is a common rock-forming mineral, and dolomite is made up of calcium magnesium carbonate. And this is the chemical formula of dolomite. Now, dolomite is the primary component of the sedimentary rock known as dolostone and the metamorphic rock known as dolomitic marble. And limestone that contains some dolomite is known as dolomitic limestone. So before we continue, again, dolomite is made up of calcium magnesium carbonate. And this is the chemical formula of dolomite. So as you could see, dolomite is made up of calcium magnesium carbonate. And if dolomite is present in sedimentary rock, we call that dolostone. Now, if dolomite is present in metamorphic rock, we call that dolomitic marble. And if limestone contains dolomite, we call it dolomitic limestone. Okay, so at this point, let us now examine the physical properties of dolomite. Now, in terms of its cleavage, dolomite has three directions of perfect cleavage, as you could see in the picture. And in terms of hardness, dolomite has a Mohs hardness of 3.5 to 4. Now, in terms of fizz, dolomite produces a very weak reaction to cold dilute hydrochloric acid. Now, however, if the acid is warm or if the dolomite is powdered, a much stronger acid reaction will be observed. And powdered dolomite can easily be produced by scratching it on a streak plate. So those are some of the physical properties of dolomite. Now, what are some of the uses of dolomite? Now, as a mineral, dolomite has very few uses. Now, however, dolostone has an enormous number of uses because it occurs in deposits that are large enough to mine. And the most common use of dolostone is in the construction industry. It is crushed and sized for use as a road-based material, an aggregate in concrete and asphalt, railroad ballast, riprap, or fill. Now, dolostone is also calcinized in the production of cement and cut into blocks of specific size known as dimension stone. And also, dolomite's reaction with acid also makes it useful. It is used for acid neutralization in the chemical industry, in stream restoration projects, and as a soil conditioner. Now, what does this mean? Now, if you will recall when we studied the physical properties of dolomite, if you place 1 drop of cold hydrochloric acid on a piece of dolomite, the reaction is weak or not observed. Instead of seeing an obvious fizz or bubbling, you will see a drop of acid on the surface of the mineral that might have a few bubbles of carbon dioxide gas slowly growing on the dolomite surface. Now, however, if warm acid is placed on dolomite, an obvious fizz or bubbling will occur. This occurs because the acid and rock reacts more vigorously at higher temperatures. Now, if you place a drop of hydrochloric acid on powdered dolomite, a much visible reaction will occur. This is because the surface area has been increased, making more dolomite available to the acid, and because of its carbonate nature, dolomite makes a good acid neutralizer. So you have to take note that dolomite reacts weakly in hydrochloric acid. But if the dolomite is in powdered form, then dolomite reacts strongly with hydrochloric acid. Now, dolomite is also used as a source of magnesia, a feed additive for livestock, a sintering agent, and flux in metal processing. And also dolomite is used as an ingredient in the production of glass, bricks, and ceramics. So, from what you have learned about dolomite, what can you say about the use of dolomite in beach nourishment in Manila Bay? Alright, so let's watch some videos about this controversial issue of using dolomite in beach nourishment in Manila Bay. So let's watch this.
What is dolomite? Dolomite is an anhydrous carbonate mineral composed of calcium magnesium carbonate. The term is also used for a sedimentary carbonate rock composed mostly of the mineral dolomite. An alternative name sometimes used for the dolomitic rock type is dolostone. Most probably the mineral dolomite was first described by Carl Linnaeus in 1768. In 1791, it was described as a rock by the French naturalist and geologist Dieudonné de Dolomieu, 1750–1801, first in buildings of the old city of Rome, and later as samples collected in the mountains now known as the Dolomite Alps of northern Italy. Nicolas Théodore de Saussure first named the mineral, after Dolomieu, in March 1792. Properties of dolomite: the mineral dolomite crystallizes in the trigonal rhombohedral system. It forms white, tan, gray, or pink crystals. Dolomite is a double carbonate, having an alternating structural arrangement of calcium and magnesium ions. Unless it is in fine powder form, it does not rapidly dissolve or effervesce, fizz, in cold dilute hydrochloric acid as calcite does. Crystal twinning is common. Solid solution exists between dolomite, the iron-dominant ankrite and the manganese-dominant kutnohorite. Small amounts of iron in the structure give the crystals a yellow to brown tint. Manganese substitutes in the structure also up to about 3% MnO. A high manganese content gives the crystals a rosy pink color. Lead, zinc, and cobalt also substitute in the structure for magnesium. Because dolomite can be dissolved by slightly acidic water, areas of dolomite are important as aquifers and contribute to karst terrain formation. Chemical composition: ferrous iron commonly substitutes for some of the magnesium in dolomite, and a complete series very likely extends between dolomite and ankrite. Manganese also substitutes for magnesium, but typically only to the extent of a few percent and in most cases only along with iron. Other cations known to substitute, albeit in only relatively minor amounts within the dolomite structure, are barium and lead for calcium and zinc and cobalt for magnesium. Nearly all the natural elements have been recorded as present in at least trace quantities in dolostones. It is, however, unclear which ones actually occur in the dolomite. Some of them may occur within other mineral constituents of the analyzed rocks. Indeed, only a few of these elements, example strontium, rubidium, boron, and uranium, U, are known definitely to occur within the dolomite structure. Uses of dolomite: dolomite is used as an ornamental stone, a concrete aggregate, and a source of magnesium oxide, as well as in the pigeon process for the production of magnesium. It is an important petroleum reservoir rock, and serves as the host rock for large strata-bound Mississippi Valley type, MVT, or deposits of base metals such as lead, zinc, and copper. Where calcite limestone is uncommon or too costly, dolomite is sometimes used in its place as a flux for the smelting of iron and steel. Large quantities of processed dolomite are used in the production of flowed glass. In horticulture, dolomite and dolomitic limestone are added to soils and soilless potting mixes as a pH buffer and as a magnesium source. Dolomite is also used as the substrate in marine, saltwater, aquariums to help buffer changes in the pH of the water. Calcined dolomite is also used as a catalyst for destruction of tar in the gasification of biomass at high temperature. Particle physics researchers like to build particle detectors under layers of dolomite to enable the detectors to detect the highest possible number of exotic particles. Because dolomite contains relatively minor quantities of radioactive materials, it can insulate against interference from cosmic rays without adding to background radiation levels. In addition to being an industrial mineral, dolomite is highly valued by collectors and museums when it forms large, transparent crystals. The specimens that appear in the magnesite quarry exploited in Yugui, Esterobar, Navarra, Spain, are considered among the best in the world. Here in the Philippines, the DENR has started mobilizing a fleet of earth movers and other heavy equipment and started pouring what looked to be white sand, similar to that of popular beach destination Boracay, on a 500-meter stretch of the bay's naturally gray shoreline in Manila, near the Biwal K Strip along Roxas Boulevard. The project is part of the Manila Bay Rehabilitation Program launched by Environment Secretary Roy Cimito in January 2019 to save the bay from decades of pollution and urban blight, as ordered by the Supreme Court. The said project is estimated to cost around P397.9 million, according to the Department of Public Works and Highways for the beach nourishment, coastal restoration, and enhancement of the Manila Baywalk area.
Mainit na usapin ngayon ang tungkol sa dolomite o tila white sand na itinatambak sa shoreline ng Manila Bay. Matagal na ang industriya ng pagmimina ng dolomite sa Pilipinas, pero ayon sa ilang mga eksperto, maraming risk ang kaakibat nito. Isa ang Pilipinas sa top exporter ng dolomite sa Japan ayon sa data na inalabas ng World Bank noong 2018 kung saan naabot to sa 59 million kilograms o 59,000 metric tons. Sa buong mundo naman, nasa pang-19 tayo sa exporter nito. At sa Alcoy, Cebu ang isa sa pinakamalaking site ng pinagkukunan ng dolomite sa Pilipinas.
Dalawa lang ang alam ang nasa listahan ng dolomite, pero ito medyo malaki siya to operate in 2 towns, yung Alcoy at Dalaguete. Medyo malaki siya at 500 hectares. Yung mining contract niyan was only recently, mga 2005. At so kung 25-year yung mining contract niyan, hanggang 2030 pa yan.
Ang dolomite ay isang uri ng sedimentary carbonate rock o yung bato na may mineral content. Madalas itong gamitin sa production ng glass, bricks at ceramics.
Kung full commercial operation sila in the past 15 years, I'm actually surprised na hindi pa totally flat yung area na yan. Which means na hindi pa nila talaga nakukuha lahat ng kanilang mineable areas. Walang duda yung impact niyan doon sa vicinity would be pagkawala ng watershed.
Maraming netizen ang nakapuna na tila kalbo na ang lugar na pinagmiminahan ng dolomite.
Dahil nawala na yung watershed, yung ability niyan to absorb water at mag-produce ng water ay talagang napakahihina na and kulang. Yung pollution, syempre, because of the dust and the operations niyan, we can only imagine yung impact niyan sa air pollution and eventually sa health ng mga tao.
Pero para sa ilang mga Cebuano, hindi sila tutol sa industriya dahil malaki ang naitutulong nito sa kanilang ekonomiya. Ikinagulat din ng publiko ang maaaring maging epekto sa pagdadala ng 3,500 wet metric ton ng processed dolomite sa Manila Bay. Sabi ng grupong Advocates of Science and Technology for the People o AGHAM, posibleng hindi maging permanente ang dolomite na itinatambak sa Manila Bay.
Nagulat kami. I think it's a form of dump and fill activity din na isa rin sa mga tinututulan ng organization namin. Kasi yung pagtambak ng buhangin na ito ay could pose impacts doon sa Manila Bay.
Hindi raw akma ang pagtatambak ng ganitong uri ng pinapinong bato sa Manila Bay.
yung circulation doon sa Manila Bay ay paikot-ikot siya throughout the bay, ay may possibility din na maanod yung dolomite sa other areas. Isa din itong form ng pollution kasi given na foreign material yung dolomite, hindi siya naturally occurring doon sa Manila Bay. So parang nagtapon din sila ng isang bagay na hindi nakikita doon and possibly may effect din sa mga ecosystems doon.
Bukod sa risk ng dolomite at industriya nito sa kalikasan, posible ring may adverse health effects ito.
Ang dolomite naman kasi, maaari kasing magkaroon tayo ng mga allergic reactions, maaari din kasi nagkakaroon tayo ng problema sa respiratory tract natin kasi baka mamaya kasi magkaroon tayo ng parang mga maging allergen kasi siya, no, na pwede kasi makapag-trigger ito sa mga sakit.
Pero paglilinaw ng DENR, hindi naman daw delikado sa tao ang proyektong ito.
But what you can see as of now is they're saying that is dolomite dust. Ito po sa atin, this is a finished product. So there's no such thing as dolomite dust. No, this is a finished product, and yet this is not harmful to the people because in the first place, ito po ay 5 mm ang sukat. Napakalaking butil po nito, hindi po ito magsususpend sa air.
Yung very minimal or sabihin natin minute, no? Yun talaga yung pwede talagang pumasok kasi dun sa lungs natin. Na pwede kasi once kasi na, syempre, foreign body pa rin kasi siya, pwede kasi mag-cause ito ng production of mucus, no? Overproduction of mucus. Kaya pwede kasing malunod yung baga natin. Kaya pag may mga problema naman na talaga tayo dun sa ating lungs, gaya ng mga asthma, syempre, bawasan lang din naman yung pagpupunta doon.
Sumulat na ngayong araw si Manila Mayor Isko Moreno kay Secretary Roy Simato ng Department of Environment and Natural Resources para linawin ito. Payo ng Alyansa Tigil Mina at Agham Diliman, dapat daw mag-focus muna ang DENR sa mga pangmatagalang solusyon in rehabilitating Manila Bay.
To DENR, I think kailangan nilang kilalanin at tanggapin na mali itong naging gawain nila na mag-beautify ng isang parte ng Manila Bay. Sa panahong ito, mali yung timing, mali yung pamamaraan, at mali yung mensahe na naipaabot nito sa mga ordinaryong tao. In a pandemic setting that we have right now, kung hindi na-mitigate ng maayos yung dust at pollution, air pollution in that area, we doubt na makakatulong yan sa health situation ng probinsya.
Kung yung ultimate goal ng gobyerno ay mapangalagaan yung coast, malinis yung karagatan, at tuluyang ma-rehabilitate yung Manila Bay, ay mas mainam na panatilihin yung mga natitirang mga mangroves sa buong Manila Bay.
Samantala, nag-issue na ng cease and desist order si Governor Gwendolyn Garcia para sa Dolomite Mining Corporation at sa mineral processing permit holder nito na Philippine Mining Service Corporation. Pansamantala munang ipinatitigil ang extracting, processing, selling and transporting ng dolomite sa Cebu. Lalo na't isang environmentally critical area raw ang Alcoy kung saan naninirahan ang endemic at endangered na siloy o black shama ng Cebu. Hindi kinakailangang magtibag ng isa pang bundok para pagtakpan ng isa pang yaman na nasisira. Hindi matatakpan ng pagpapaganda ang kalagayan ng Manila Bay. Sana mas maging siyentipiko ang sistemang ipatupad sa pagsasaayos at paglilinis nito at umaksyon ng naayon sa kalikasan. I'm MJ Jeronimo, I stand for truth.